Hello and welcome back to another video. Here we are going to solve the last three questions from 970953, that is S1 of October-November 2020. So here is the question number 5. The 8 letters in the word reserved are arranged in a random order. Find the probability that the arrangement has V as the first letter and E as the last letter. So we need to find the probability. So first of all, we'll find the favorable case, number of favorable case where the first letter is V and the last letter is E. So altogether there are 8, so remaining 6 will fixed here. So we can arrange these 6 letters in 6 factorial ways, and we can see there are 1 2 3 e's, but one e is fixed, so only 2 e's are left. So 2 factorial, and 1 2 2 r are there, so of course again 2 factorial. So this is the total number of ways we can arrange these letters, 8 letters, so that V is always going to be at first place and E as the last place, and divide by the total arrangement. And total arrangement of 8 letters are 8 factorial. Divide by the number of letters which are same, 1 2 3 3 factorial, and 2 r are there, so 2 factorial. So this is the answer, this is the probability, and we can see these two got cancelled, and we can rewrite it as 6 factorial. We can write 6 factorial, and it is 8 factorial, so I'll write 8 into 7 into 6 factorial, and here divided by 2 factorial, so 2 factorial got cancelled, we are only left with 3. So 3 got 6 factorial got cancelled, 3 will be in the numerator, and 8 7s are 56. So the probability is going to be 3 over 56. Here's the B part. Find the probability that the arrangement has both r's together, given that all 3's are together. It is already given that 3 e's are together, then we need to find the probability that both the r's are together. So first of all, we'll write the word. It is RESERVED. Now if it is given, that means conditional probability, then we need to find the probability of r's together, given that means vertical line e's are together. So this is going to be probability of intersection of these two r's together. I'll only write r's and e's, divide by the probability of e's together. So let's find first of all what is the probability of r's and e's together. So first of all, the number of arrangement when r's and e's are together, so we can take 2 r's here, 3 e's, and then remaining 1 2 3. So we have 1 2 3 4 5 numbers, 5 alphabet to write, so it is going to be 5 factorial, and divide by the total arrangement, and total arrangement is going to be like total, there are 8 alphabets, so 8 factorial upon 2 times r, so 2 factorial, and 3 times e, so 3 factorial. So we will calculate this. It is going to be 5 factorial into 2 factorial into 3 factorial, divide by 8 factorial. Now we will calculate the probability when e's are together. So e's are together, we have 3 e's, and then remaining 5 letters can be anywhere. So we have 1 2 3 4 5 6. We can arrange them in 6 factorial ways, and since there are 2 r's also in these arrangements, so we will divide by 2 factorial, and whole divide by the total arrangement, that is same, 8 factorial over 2 factorial 3 factorial, that is We can cancel 2 factorial gone, so we are left with 6 factorial into 3 factorial over 8 factorial. Now we will solve it. It is going to be 5 factorial into 2 into 3 factorial over 8 can be written as 8 into 7 into 6 into 5 factorial. Now these two got cancelled. 3 factorial is 6, so this is also got cancelled. 2 1s are 2, 4s are, so it is 1 over 28. And here it is 6 factorial into 6 upon 8 factorial is, we can write 8 into 7 into 6 factorial, so these two got cancelled. We are left with 2 3s are 6, 2 4s are 8, so it is 3 over 28. 4 into 7 is 28. So the required probability is 1 over 28 upon 3 over 28, that is 1 over 3, and that's the answer. I hope it was of some help. Let's discuss the next question. Now here's the sixth question. 3 coins A, B, C are thrown once. Coin A and B are each biased so that the probability of obtaining a head is 2 by 3. Coin C is biased so that the probability of obtaining a head is 4 by 5. First part is to show the probability of obtaining exactly 2 heads and 1 tail is 4 by 9. So we are going to draw all the possibilities here. A, B, C, all the 3 coins. Now we'll find all the possibilities. 2 heads, so on all the 3 coins we have possibilities like first coin A shows head, second coins also shows head, and third one is tail. If the first one means on A it is head, B it is tail, and C it is head again, or on A it is tail and on B and C they are going to be head. So these are the only possibilities where we can get exactly 2 heads and 1 tail. So let's find the probabilities, corresponding probabilities. So first one, getting head on A and B are same, the probability is 2 by 3. So getting tail, it would be 1 minus 2 by 3, that is of course 1 by 3. So in on A and B, if it is head, so it means 2 by 3 into 2 by 3, and on C if it is tail, so 4 by 5, it is probability of getting head in on C, then tail it is going to be 1 by 5, so it is 1 by 5. Similarly for this case, head means 2 by 3, tail means 1 by 3, and again head means 4 by 5 on C. So the third one is getting tail on first A is 1 by 3, getting head on B it is 2 by 3, and getting head on C again it is going to be 4 by 5. So altogether we have 4 over 3 3 is 9, 5 is 45. For this case it is 8 over 45, and for this it is again 8 over 45. So total probability is, required probability is going to be 4 by 5, 4 by 45 plus 8 by 45 plus 8 by 45. So we can write probability of getting x, means if you take x as head, so it would be 2 head is going to be 8 8 16 plus 4 20, 20 over 45, or we can divide by 5 and we will get 4 over 9. So that is the probability given, so hence it is proved. Let's discuss the B part. Now the random variable x is the number of heads obtained when the 3 coins are thrown. Draw up the probability distribution table for x. Now x is given as the number of heads, so the possibilities for it would be, there would be no heads, there can be 1 head, or there can be 2 head, and the last there can be all the 3 heads. So for 0 head, no heads, it means on all the coins there are tails, tails and tails. And for 1 we have solved for 2, but for 1 we can calculate it as for A it is tail, and B it is tail, and for C it is head, because only one heads we want. Or it is the possibility that on A it is tail, second it is head, and the third it is again tail. Or from A it is head, B it is tail, and C it is again tail. No other possibilities, because we require only one head, so these are the only possibilities. For 2 we have it already from the previous part. It was 20 over 45, that is 4 over 9. And for 3 it means all the coins shows head. So let's find the probabilities. So for this, probability would be for A, I'll write A, it is 2 by 3 getting head, and the same is for B. For C it is 4 by 5. So the tail, for tail we will get 1 by 3 here, and for tail here we will get 1 by 5. So let's write it: 1 by 3 into 1 by 3 into 1 by 5. Here it would be 1 by 3 into 1 by 3, and head on C it is 4 by 5. 1 by 3 and 2 by 3, and it is tail, so 1 by 5. For the third one it is 2 by 3, then 1 by 3 and 1 by 5. Here it is given. And for heads means 2 by 3 into 2 by 3 into 4 by 5, because on C it is 4 by 5. Let's make the table and put the values. Here we will put x is equal to x, that is going to be 0, 1, 2, 3, and here the probabilities of corresponding values. 0, for 0 it is 1 over 45. For 1 it is 4 from here, 2 from here, 2 from here, 8 over 45. And from here it is 20 over 45. And here 4 4 is 16 over 45. Now again we'll check it whether it is correct or not. 16, 20, 36 plus 8, 44, and plus 1, 45. So it is correct. Let's do the next question. Now the C part. Given that expectation of x is 32 over 15, find the variance of x. So variance of x, we know it is expectation of x square minus expectation of x whole square. So for expectation of x square means the square of all the values and its corresponding probabilities. So 0 into 0 square into 1 over 45 plus 1 square, that is 1 into 8 over 45 plus 2 square, that is 4 into 20 over 45 plus 3 square, that is 9 into 16 over 45 minus square of the expectation, and it is given 32 over 15, so square of it. So let's calculate. 1 from here, 0 from here, 8 and 80, and here it is 69 over 144. So it become 8 plus 80 plus 144 whole upon 45 minus 32 over 15 whole square. Now we will calculate. So this value altogether it is 136 over 225, or in decimal also we can write it is coming 0.60444 and so on. That is of course 0.604 only. So that's the answer. Let's discuss the next question now. Here's the last question of this paper, that is 7th question. A particular piece of music was played by 91 pianists, and for each pianist the number of incorrect notes was recorded. The results are summarized in the table. number of incorrect nodes 1 to 5, 6 to 10, 11 to 20, 21 to 40 and 41 to 70, and its corresponding frequencies are 10, 5, 26, 32 and 18. So draw a histogram to represent this information. So for histogram we require y-axis as frequency density, so we'll write frequency density here, and before that we require the width of the class interval. And class interval, it is 1 to 5 and 6 to 10, so we need to fill this gap. So the way to fill the gap is we divide this width into equal two parts. 5 and 6, there is a 5.5, so the limits for the first interval, this is going to be the upper limit, and for the second interval it is going to be the lower limit. So the first interval is 0 to 5.5, similarly it would be 10.5, then it is 20.5, it is 40.5. so these are the new intervals. So width would be 5, frequency density is going to be 10 over 5, it is 2. For this it is 5 over 10, 5, that is 1, and 26 over here the gap is 10, so it is 2.6, and 32 over the gap is 20, so 20, it is going to be 1.6, and here it is 18 to 70.5, 40 to 70.5, 30, so 18 divided by 30, it is 0.6. Now once we have the width, class interval and its corresponding frequency density, we are going to draw the histogram. And here is the histogram I have drawn already, and here it is 2, here it is 1, here 2.6, and this is 1.6, and here it is 0.6. so these are the frequencies and frequency densities. These are the number of this is the interval, and here it is frequency density on y-axis. Let's discuss the next question of this. Now here's the B part. State which class interval contains the lower quartile and which class interval contains the upper quartile, and hence find the greatest possible value of interquartile range. So interquartile range, for that lower quartile is going to be 25% of the total data. So 25%, this was 91, it was given in the question, there are 91, otherwise also we can add them and get the value. So 91, so 725, we'll find the 25% of 91 and we'll see where this value will lie. So it is 22.7. before that we can find the cumulative frequency so that we can get the value. It is 10 here, it is 15, and here it is 41, and here 43 plus 43 and 30, 73, and then here it is 91. So 22.75 will lie in this interval, because it is still here till 10, 6 to 10 it is only 15, till 10 it is 15, so 25% of 91, which is of course 22.75, will lie in this. So lower quartile will be in 11 to 20 class interval, and upper quartile of course we'll find the 75% of it. So 75% of 91 is going to be 68.25, which is of course going to be in this interval, that is in 21 to 40, and hence greatest possible value of IQR would be the upper limit minus the lower limit of lower quartile, that is 40 minus 11, and we know 40 minus 11 is going to be 29, so that is going to be the greatest possible value of interquartile range. Now here is the C part, that is the last question, and calculate an estimate for the mean number of incorrect nodes. So for mean, we require the mid value in the group data and the frequency, and here the mid value is 1 plus 5 divided by 2 is 3, 6 plus 10 divided by 2 is 18, 11 plus 20 divided by 2 is 15.5, 20 plus 20 plus 6 21 plus 40 is 61, divided by 2 is going to be 30.5, so it is 30.5, and 41 plus 70 divided by 2 is going to be 55.5. So the mean would be the sum of this data divided by the total number of data, that is, of course, we know 891, and numerator would be 3 into 10 plus 8 into 5 plus 15.5 into 26 plus 30.5 into 32 plus 55.5 into 18. Now we will calculate this value. It is 2448 divided by 91, and this value is going to be till three significant figure is 26.9, because it is 26.901 and so on. So that's the mean number of incorrect notes. So that's it for this video. We'll discuss the next RC paper in the next video. Till then, thank you so much.